Hello dear students, welcome back to my YouTube channel of Pharma Learning. Today I am going to have the another video on the another unit operation which is known as mixing. As you know that the mixing is a unit operation which basically involves only the physical change into which two or the more or components are separate or in the roughly portion they are mixed together so that each particle of each of the components lies as close or as nearly possible to the another particles. So the mixing is a unit operation to which we try to mix either solid with the liquid, solid with the solid, liquid with the liquid in such a manner that the particles of either solid and oblique or liquid and oblique or solids, they are going to remain in the close proximity to the each other. So what are the final product which are obtained after the end of the mixing process, that is known as a mixer. So be careful about the word that is called as a mixer, that is mixture. The equipment which perform this mixing operations, that is known as a mixer. Here again you need to be careful about the word that is called as a mixer, that is mixer, because sometimes the students are getting confused between the word mixer and the mixer. So both are the different thing. The opposite phenomena, the opposite operations of the mixing, which is known as segregation or the separation. Now let's go into the details of what are the different types of the mixers will be there. As we know that the mixer is a end product at the end of the mixing. So the mixers will be of the two type, heterogeneous or the homogeneous. As shown into this particular slide, there are the two color balls are there. One is a blue color, another one is a purple color. Now look at the diagram which is shown over here in the heterogeneous mixer. Here both of the different, consider like that the one single ball is a one of the particle of the one of the component. So here the blue and the purple ball, they are randomly arranged, while in the case of homogeneous mixer as shown it over here, this both, that is the both the components of the particles, that is shown by over here the purple and the blue color, they are arranged in the definite fashion one after the another. So that is known as a homogeneous mixer. Why we are going for any of the mixing process? Basically we are carrying out the mixing process with the following objectives: to produce the simple physical mixer, to produce the physical change as it is defined in the unit operation, to produce the dispersion or the semi or the dosage form like suspension phase emulsion, and to promote or to enhance the chemical reaction. Now sometimes the mixing word is going to be confused with the word blending. So let's try to understand what's the difference between the blending and the mixing will be there. Blending word we are using when we are trying to mix two solid components. So it is with respect to the solid dash solid mixing. While the mixing word is basically used when we are going for the liquid-liquid mixing or the gas-liquid mixing. The blending word is generally used when we are going for the mixing of the bulk solid, the solid one of the solid which is present in a large amount with the small amount of liquid also. So that is also known as the blending. Now let's try to understand how the mixing process will take place. What are the mechanisms of the mixing? So the first mechanism of the mixing, that is called as a diffusion. If you try to understand the simple meaning of the word diffusion, means it is the transfer of the particles or the components from the high concentrations towards the lower concentration. So here the particles of the solids are going to move randomly, typically that is going for the depending upon the concentration gradient, and they are moving locally when the container is rotated. The simple example of this diffusion mixing we find in the case of V blended and the double cone blender, which are the mixer which are basically used for the solid-solid mixing. Now, what are the advantages and the disadvantages of this diffusion? In the case of diffusion, we require the lower energy. It's very simple process. The gentle mixing is carried out and it's reliable, and afterward the mixer is easy to clean. If you look at the other side of the coin, that is a disadvantage of the limitation, then we can say the mixing in this case is time consuming. So it's required a longer time. We cannot achieve the good mixing of the powders if they are having the broad or the different particle size distribution. And segregation experience means the separation also can be taking place if we are allowed to stand that mixer for the long period of the time. Another mechanism that is taking place in the mixing, that is called as convection. In the case of convection, the mixing tool, either we are using whatever the force device that will try to enhance the mixing process, either the paddle or the gentle tumbling under the rotation, whatever it may be, which is useful for moving the large group of the particles and splitting that into the bulk of the particles, and thereby we are going to achieve the mixing. The example of the mixer which work on this principle, that is the ribbon blender, screw blender, and the paddle mixer. Okay, let's try to understand the what are the difference, what are the advantage and the disadvantage of this convection will be there. In the case of convection, it requires a shorter mixing time as well as a low energy, so we can get the more uniformity of the distribution of the particles compared to the diffusion mechanism over here. While if you look at the disadvantage, then again it's required a longer time, so the mixing process will be lengthy. The equipment of the mixer is complicated because we have the rotating devices or the rotating components like paddle, tumbler, etc. And these are the mixers are not easy to clean. The third mechanism, that is called the shearing. The shearing means we are going to apply certain force. So here we are again using the mixing tool, which is rotating at a very high speed, and that will apply the shear force to make the group of the particles slip into the one another and also help in the breaking of the agglomerates. So as shown in the diagram over here, in the first step we are going to apply the shearing force. Look at these particles are ununiformly distributed. So when we are going to apply the shearing force over here, so the uppermost layer will move on the right side, the lowermost layer is going to be move on the left side. It is like a comparative movement. So when the upper component of the upper layers are going to be moved on toward the right side, and let's try to assume that the bottom layer is going to be stationary. So here the particles are going to be distributed by the shearing force, and later on they will going to be distributed by the convection and the diffusion mechanism as shown. So here we try to get the more uniform particles distribution. Again, looking at the two sides of the coin, there is the advantage and the limitations. So in this kind of the shearing, we require the shorter mixing time. Yeah, that was a disadvantage in the case of diffusion and the convection. Yeah, there are also less chances of agglomeration, and it is continuous in the operation. While looking at the other side of the coin, that is, higher energy is required. The chances are that the particles may broken down because of the high energy provided, and because of that particular thing the cost of the mixer is going to be higher. So in nutshell, I can say that whenever the mixing process is going to be taking place, it is going to be taking place not simply by the one of the mechanism, but it is going to be taking place by the all the three mechanisms, that is the diffusion, convection, and the shearing together in the more or the less proportion. Now let's try to understand another one, the word that is called as a mixers. As you know that mixer is an end product of the mixing. The mixers are basically of different three types. The first one that's called the positive, negative, and the neutral. It is considered like when we are looking at the scale in the center we have the zero, so that is let's consider like a neutral. When we are rotating, when we are moving on the scale to the left hand side, so when we are having the negative number, so it's like a negative mixer. When we are moving on the right hand side, it's a positive number, so it's a positive mixer. Okay, let's try to understand the first positive mixer. As the name suggests, it's a positive, so it do not require any energy, and it is not going to create any problem during the mixer, and so during the mixing cycle there is no problem, and afterwards the mixer is allowed to stand for a longer period of the time or unlimited period of the time. It's not going to be separated out. So the simple example of the two on this positive mixers will be that that's a two or the more gases, because as you know that the gas particles are moving randomly, they are diffused with either each other or the one another very easily. And another example of the that is positive mixer is like a miscible liquids. Take the example of the water with the alcohol. They are going to be distributed or they are going to mix very easily. Take the example of the water with the glycerin also. Now let's go for the negative mixers. Yeah, as the name suggests, yes, we'll have to work on that one. So it required energy. After the mixer is formed, if we are going to allow for the stand for a longer period of time, it is going to be separated out. The example of this one is let's say two immiscible liquids. Okay, like water and the oil, when we are mixed together, okay, they are getting mixed and we are forming the this form or the dispersal, which is known as emulsion. But we are allowed to keep it for a longer period of time, yes, then the water and the oil molecules are going to be separated. Another example is insoluble solid and the liquids. So when we are going for mixing the insoluble solids with the liquid, that dosage form or the dispersion is known as a suspension. If we are allowed to keep the suspension for the longer period of time, usually depending upon the gravitational force and the sedimentation phenomena take place and the settling down of the insoluble particles will take place. Now let's try to go with the third type of the mixer, that is called the neutral mixer. As the name suggests, the neutral mixers do not form easily, but the thing is that once they are formed, they are not going to separate out easily. The simple example of this particular neutral mixer is a paste. Generally, we are using the toothpaste in the morning, so into which insoluble solids are going to be distributed into the liquid to give the semi-solid consistency, so it's not going to separate it. Another type of the semi-solid dosage form that comes into this neutral mixer, that's called as ointment. And the third one, that is called as a mixed powder. The mixed powder means when we are going to mixing the solid with the solids. Okay, it is an example of the neutral mixer into which the powder components are not going to separate it out easily. So this was all about the introduction to the unit operation mixing. I highlighted what are the different terminology like a mixer, mixers, and what are the mechanisms of the mixing, what are the types of the mixers will be there. If you like my video, please give it like, share with another one, and please subscribe to my channel for upcoming new videos on the mixing and another unit operations. Thank you.